So this question is the discrete, or a question about discrete random variables. So we've got a table, we've got a missing value, we've got 2 bits of information we've been given to help us do this. Now, interestingly, the way I started this was by using the fact that the expected value of y was less than 0. So, you know, to work out the expected value of y, you do your y values times the probability y equals y and add them up, so the sum of that. So that's a half times a plus 2 times 3 over 10 plus 7 times a fifth is less than 0, which leads you to the fact a is less than negative 4. But you'll see later, actually, you don't need to do that because you can work out logically what a is anyway, but we'll come back to that. So we've told the variance is 28. Oops, variance of y equals 28. Now, the variance is the expected value of y squared minus the mean of y all squared. And so that's going to be equal to 28. Okay, so if I want the expected of y squared, I need to do every y value squared times its probability. Okay. And then take off the mean squared. So this was my formula for the mean. If you simplify that, that simplifies to a half a plus 2 and squared, and that must be equal to 28. We can then expand and simplify all of that, and you can rearrange that to get to a quadratic equation. Which you can solve in any of your usual quadratic methods. And these days you can just put that in your calculator. So you get a is 14 or negative 6. From above, we know a is less than negative 4. Therefore, a equals negative 6. But as I said, we didn't actually need to do the working out to find a is less than negative 4. For a start, if you look at the table, usually these tables would be done in order, so it makes sense that that's negative 6, because that would fit in numerical order. The other fact is the mean's got to be less than 0, where if a was 14, you'd never get a mean less than 0. Just by thinking about it, you wouldn't even have to work that out. So a must be negative 6. Okay, so that was the first part. In the second part now, we want to find the expected value of 1 over 3 minus y. Now, what we got to note here, that this is not linear. Now, by linear, you're thinking of an expression of the form ay plus b. Right, think of a straight line graph in the form of a straight line graph, and this is not linear. It's 1 over 3 minus y. That means you can't use coding. You have to actually work out all the values of 1 over 3 minus y and do them in again. Okay, so I've just given us a bit more space to do that. Okay, so I've got y, I've got 1 over 3 minus y, and I've got the probabilities. Very quick rough table. So y is negative 6 to 7, and then I just work out what 1 over 3 take away negative 6 is, and then this will be 1 over 3 minus 2, and then we've got 1 over 3 take away 7. Okay, now the probabilities don't change. You never change the probabilities. They've got to always add up to 1. Okay, and now I just work out the mean using these 2 rows. So expected value of 1 over 3 minus y. So now we just do all of those values times their associated probabilities, which gives us 11 over 36.